Normally I don't record the warm-up, but like I said, today's warm-up is going to be the same concept for the whole thing. So who can tell me where they see 8 in the equation and in the graph? Ryan?
The line is the Y-intercept.
Yeah, we're talking Y-intercept right up in there, right? What about in the function? Where do you see it in the equation? Yeah, it's the 8, yeah. It's the constant. Remember that word yesterday? It's the constant in this. Meaning the slope has no effect on it where it is, right? So in context, whatever is happening, it's starting at 8. All right? And then who can tell me where we see the -2? Troy?
The slope.
The slope. So I'll hold down 2, write one thing, right?
It's also the -2 in the equation. Oh.
And there's also right here, there's the slope of the linear part, right? When we learn that term for our quadratics, the linear portion. 3 is really the one that's going to pop. The only thing I want to point out is this value of 8 right here, it happens when x is 0, right? When x is 0, that's this whole axis when x is 0. When x is 0, what does y equal? 8. 8. And the reason is something times 0 is 0. Okay? Vinny, where do you see the x-intercept on the graph?
Actually at the x.
Right here?
Yeah.
So what is it?
It's the slope or
The x-intercept.
Oh, it's 4.
It's 4. Now who can tell me where they see 4 in the function? 4 in the function. Vinny?
Oh, I see it in the x.
You see it in the x?
Yeah, I see it in the x.
Okay, that's cool. Here, let me clarify what Vinny is saying because I think it's good. He's saying he knows if he does 8 minus 2 times 4, it's 0. Which is 4, 0. Now, let me show you. I see it the same way, only different. I see it right here. The x-axis, no matter where I'm at on this axis, what does y equal?
0.
It has to equal 0. So I see 0 equals 8 minus 2x. And x would have to be 4 to equal 0.
Oh my God,
Which is what Vinny said. We just, yeah. For this, we're going to revisit throwing stuff. We're throwing up, okay? We're starting where? Let's look at the function. Where are we starting looking at the function? Yeah, we're throwing up from 10, okay? And how fast are we throwing up? 78. And what's the other force on us throwing up? Gravity. And how do we know it's gravity?
16t squared.
16t squared is still there. So your job is, number 1, is it written in standard form? Number 2, is that the same function? Number 3, identify the vertical and horizontal intercepts, also known as the x and y intercepts. And then what those places mean in context. All right? This is all stuff we've been doing. We're going to make a big connection here after we get to problem 2. So do all 3 of these, please. Let's talk about this equation. Riley, is it written in standard form?
Yes, it actually is.
How do you know that?
Um,
Not like I'm surprised, you know. Like, I want you to justify it.
because it's simplified already.
Okay, so simplified. Anything else you can point to?
Not at this moment. No parentheses.
No parentheses. Yeah, that'd kind of go with this.
I don't think you can like subtract 78t minus 16t.
Yeah, Ivy?
It like constant,
Constant,
linear,
linear, and quadratic. Yeah, we have all those elements of the standard form that we saw yesterday. So no parentheses, nothing to simplify. We've got a constant, linear, and quadratic portion. Now, who can tell me how they tested out this factored form to see if it was the same? Yeah, Sean.
I distributed the -16t.
Okay, so when you distribute, you get -16t squared plus 80t minus 2t plus 10.
Yes.
And then
Jada's pretty smart.
when we combine like terms, we get the same expression, right?
Jada's
It's in a different order, but it's the same thing, right? Okay, so Jada is right. Checking the graph. Who can tell me what they think the vertical intercept, also known as the y-intercept, is? Yeah.
10.
It's 10. It's right here, right? Now, next question, though, which isn't on here. Where do we see that in either equation? Where can we see that in either equation? For you, Kyle.
Constant.
The constant, right there. There it is. This is the y-intercept, right? When t is 0, what happens to both of these terms? They're 0, right? So it's 10. 0, 10. That's the y-intercept. Now this one's the tricky one. Who can tell me the x-intercept, also known as the 0? Cam, you got it?
What?
What's the x-intercept or the 0?
Hold up. 5.
5, right here. And so we know that that is 0.50, right? So when x-intercept happens, what does y need to be? 0. So I'm looking at this function now for that. Who can tell me where we see that in that function? Brandon?
So, wait, what part of
Where are we seeing the x-intercept up in there?
that's when the ball hits the ground.
It hits the ground right here. Okay, I like that. It hits. And this is where we throw up from. Okay? Now, but in this function that I circled right here, what in that tells us 5? Sean, where are you seeing it? The t minus 5. So I'm not going to tell you exactly why yet, but that is the spot. That's where I'm getting the 5. Now there's other stuff here. That other stuff is going to be because if we didn't have context, it would like cross the x right in there too, right? But we have context to know we can't go back in time. What we do next is going to like hopefully make it pop why this is working. The big idea I wanted you to keep in mind as you go through these next, there's 6, even though you only see 4 up here. The x-intercept happens when y is 0. The y-intercept happens when x is 0. All right, start looking for where you might see your x-intercepts in the graphs and in the functions. Let's go. All right, so I'm going to draw on here. Who can tell me, let's start with the y-intercept for number 1. Rap, you got me? Y-intercept for number 1, where is it? 3, it's right here. And where do you see it in the functions? Which function and where? Yeah, right here. And that works because when x is 0, what is y? 3. Because 0 plus 0 plus 3 is 3. Okay. Now, I'm going to continue. I'm going to point out the first couple here, and then I'm going to ask for help. Who can tell me, though, what the x and y intercepts are by... Well, let's write this down. Guys, I saw Meredith doing this. I like seeing that for the y-intercept. What's the x-intercepts? Ava, you got me? -3 and -1. And I love seeing those listed like this. -3, 0, -1, 0. Because there's no confusion about which is which, because once these have to send you on the x-axis, this has to send you on the y. Now let's talk about why these work. The x-intercept always happens when y equals 0. So I need to get this equation to equal 0. I mean, it's also true for this, but can you solve this for x with your skill set?
Maybe.
There's an x squared and an x you can't combine, so there's no like getting something alone, right? So, watch this. What can I multiply by to get 0? What's like the most common number to multiply by to get 0? 0. And would you agree, if I got this whole chunk to be 0, this whole chunk times this chunk would equal 0?
Yeah.
Okay? And if I could get this whole chunk right here to equal 0, this chunk times whatever this is would be 0. So therefore, I know that if x is -3, -3 plus 3 is 0, 0 times the other junk is 0. Or if I can get this x to be -1, -1 plus 1 is 0, 0 times the other junk is 0, I know that either way it pumps out a 0. And it's justified by our graph. So if I can get either one of these parts to equal 0, then it makes 0. Which is why quadratics sometimes have 2 answers. That's kind of cool, right? It's all about zeros, baby. All right.
Wow.
Top right. Troy, help me out. Where do you see the y-intercept?
4.
It's right here. Where do you see it in which function?
Top one.
Top one, right here, right? That is 0, 4. Where, Troy, let's stay with you. X-intercepts, where are they? 4 and 1? Okay, so I got 4, 0, and I got 1, 0. Now, Troy, where do you see them in the function?
I don't really have
Okay, so let's go with this. I want to multiply to get 0, correct? Because where the x-intercept is, right here, no matter where I'm at, y is 0. So I'm setting this equal to 0, okay? I want to multiply by 0 to get to 0. So what could I make this to get 0? 4. 4 minus 4 is 0. It doesn't matter what the other thing is. 0 times the other thing is 0. What could I get this to be, Troy? 1. 1 minus... Ooh, it's all about the zeros, baby. Okay. Next up, we're going Riley. What's my y-intercept bottom left? Negative 9. Negative 9 on the y. So 0, negative 9. Where do you see that in the function?
The top function.
Yeah, it's always the constant, right? Because if x is 0, or if y is 0, if x is 0, y is negative 9. All right, what are the x-intercepts?
Negative 3 and 3.
Negative 3 and 3. So I got negative 3, 0, and 3, 0. Where do we see those?
Minus 3 and plus 3.
Yeah, so this one has to be positive 3, and this one has to be negative 3. That's why we get 2 answers. Yeah, Ivy.
So are the x-intercepts always like the ones in the ones in the factored form, but when opposite?
So
Negative or not?
kind of opposite. Things get dicey if there's more than like just x plus or x minus. Like if there's a 5x plus 2 or something, it's a little different. So if we keep in mind that we need the whole thing to be 0, that more general concept, it'll always pop. Now, Ivy made a good point to me. Is the factored form is easy so far to just look at and get an answer, but I just want to show you 3 squared minus 9 works. Because what does that equal?
That equals 0.
0, and so does negative 3 squared minus 9. So like it works in both. It's just way harder to see in standard form. Way easier to see in factored form. And the last one, we're going to Vinny. Bottom right, Vinny. What's my y-intercept?
I got 0.
It's right there. And where am I going to see that? Which function? Where?
Yeah. Well, what do you mean? Like, which function?
Yeah, like where in the equation do you see this? That 0.
In the 5s. Well, the 5 on the bottom.
So let's check this out. This 0, 0 here is the y-intercept, right? And the y-intercept keeps being the constant, correct?
Yeah.
Okay, so what's the constant in the top one? Here, I'll point to it. It's right there.
Yeah. I don't know what are you asking?
I'll point to it. So I'm asking where in the function it tells me what the y-intercept is.
Yeah, okay. Well, the 0.
The constant is 0.
That's what you
So it's 0, 0. So what's my x-intercepts?
0 and 5.
0 and 5. So I've got 0, 0 for an x-intercept, and I've got 5, 0. Now, I'm going to do the hard one, Vinny. You're going to do the easy one. You ready? If that x is 0, it works, right?
Yeah.
Okay, so that's where the 0, 0 is. What does that need to be to make it work?
0.
0 minus 5? 5. Either way, if x is 0 or if it's 5, it makes it true for the x-axis. I'm going to roll through these myself just pretty quick. So I've got a y-intercept of 0, 0. It's right here. There's no constant. The other one is 5 because this has to be 5. This would have to be 0. So I got 5, 0 for my other x. And the last one only has, I have 4 still. 0, 4 for my y-intercept. It's right there. And no matter what, right, x is only negative 2. I've only got one answer there. This is the most missed question on the quiz, just as a reminder. Getting that to be standard form. Okay? So the big idea, 2 big ideas, those are in the numbers 2, 3. I'm not going to write it down. The y-intercept happens when x equals 0. When x is 0, standard form is easy to grab that. It's the constant. And when the x-intercept happens, y is 0. And when we get to factored form, that's way easier to see that 0, right? Different form, different values to the different forms, okay?